All right, half-angle identities. Let's see how we're going to derive these things. They come from, naturally, the double angle identities. So half and double, you can see how they relate to each other. So let's take a look at our two cosine double angle identities that we had. I know there were three, but we're going to look at these two. And what we're going to do in each of these is isolate the sine in this case and the cosine in that case. So doing some basic algebra manipulations, we can work this out. We get sine squared theta is equal to 1 minus cosine 2 theta divided by 2. And I'm going to take the square root of both sides to get sine by itself. So I get sine of theta is plus or minus the square root of 1 minus cosine 2 theta over 2. So you can see how this angle is half of that angle. Well, because all of our identities have been written in alpha instead of theta, and this really should be the half of the angle, we're going to do this little conversion here, and we're going to say that 2 theta is equal to alpha, and that means theta is equal to alpha over 2. So we're just going to substitute those values in, and we get sine of alpha over 2 is equal to plus or minus the square root of 1 minus cosine alpha divided by 2. So we can do the same process algebraically, work over here and try to get cosine theta by itself. So we'll do some algebra, move things around, divide by 2, take the square root, and then ultimately we're going to do that same conversion. This turns into alpha over 2, this turns into alpha, and now we have our sine and cosine half-angle identities. We're going to use these two identities to create the tangent of alpha over 2. And since we know tangent is sine divided by cosine, we can plug those identities in. We get this big mess, right? But we just need to simplify it, to clean it up a bit. And you'll see that it actually comes out to be a much nicer identity than the other two. So if we flip this around and multiply, the 2's are going to cancel. Ultimately, we get this. We need to rationalize this. So I'm going to multiply the top and bottom by the square root of 1 minus cosine alpha. It's basically the conjugate of the denominator, but I'm keeping it within the radical. You'll see why in a second. So if I do that, on the top, these two things are identical, so that's a quantity squared. On the bottom, these two things are difference of squares, so this becomes 1 minus cosine squared alpha. When you take the square root of a perfect square, they just cancel out, so we're left with 1 minus cosine alpha. On the bottom, we can replace 1 minus cosine squared using our Pythagorean identity. That's going to turn into sine squared alpha. So this is what we get. And the last simplification step is to take the square root of sine squared, and that just cancels, and we're left with sine. So we get 1 minus cosine alpha divided by sine alpha. I don't know if you noticed, but the plus or minus disappeared, and that's because no matter what we plug in for alpha here, the sine, plus or minus sine, will come out correct based off of tangent of alpha over 2. It just naturally works out. And it basically comes down to the relationship between the quadrants that alpha is in and alpha over 2 is in, and how that relates to the sine of alpha and the tangent of alpha over 2. And if you want a better explanation of that, come in and see me, and I'd be happy to go through that with you. Okay, so let's look at some example problems. Oh, wait, before that, we're going to sum up. Here are the 3 half-angle identities in case you needed them again. Okay. All right, so the sine of 165. First of all, we need to remember that this angle is half of the angle that we're going to be plugging in. So if that angle is alpha over 2, alpha is going to be 330. You just multiply by 2. So that means that when we apply our half-angle identity, we're actually taking the cosine of 330 degrees, not 165 degrees, not half of that either. Okay, we double it. So notice that there is no plus or minus sign here. That's because I've already established that this answer is positive. That's what you're going to have to do. Not every problem is just going to have a plus or minus in front of it, because you don't get 2 answers for these things. There's only 1 answer. So what you do is you look at your actual problem they're asking you to evaluate, and see what quadrant your angle is in. And in this case, this is in the second quadrant. And following all students take calculus, I know that the sign is positive in the second quadrant. So I know that this answer should be positive. So therefore, there's a positive sign here. Had this angle been something like 210 degrees or something, and that's in the third quadrant, I would know that my answer for sine should be negative. So this would be a negative radical. So you have to figure that out yourself. Okay, so once that's established, now we can evaluate what the cosine of 330 degrees is. And that's root 3 over 2. We can simplify by multiplying the top and bottom by 2. We're going to do that within the radical. And we get 2 minus root 3 on the top. We get 4 on the bottom, which is good because that's a perfect square. And we end up getting our answer. And I know our answer has a radical within a radical. That's okay. They're going to be complicated like that, but still correct. All right, so now let's take a look at how to use that tangent identity, the tangent of 105 degrees. So when I apply this, I'm going to double this angle. So this is 1 minus the cosine of 210 divided by the sine of 210. And I get this from this calculation. Okay, so there's no radical that I need to worry about other than maybe what I get when I evaluate the cosine and sine of 210 degrees. So if I do that, the cosine of 210 is negative root 3 over 2. So 1 minus a negative root 3 over 2. And on the bottom, the sine of 210 is negative 1/2. So to simplify, if I multiply top and bottom by negative 2, I get negative quantity of 2 plus root 3. That's it. That was it. That's all you had to do. Piece of cake, isn't it? We like that. Okay, so there you go. Those are your half angle identities. Good luck. I hope you get these things all memorized and worked out straight in your head. See ya.